Prabha Center for Nursing Education and Service. In this session, we will be dealing with the central tendency. So, we are going to define the different concepts, appreciate the different approaches and formula of mean, median and mode. Okay. So, why we need to use the central tendency? What do you mean by central tendency? Because we are dealing with the data by using descriptive statistics and inferential statistics. When we use the descriptive statistics, we apply this concept of central tendency in order to interpret the analyzed data. The commonly used central tendency are mean, median and mode. Let's see the definition given by Simpson and Kafka. They explain central tendency as a typical value around which other figures congregate. It's a single value which represents a whole series and is supposed to contain its major characteristics. Why we are using this average? We just want to use a single value which represents the characteristic of the collected data. And we can use this one to facilitate comparison. What are the characteristics of good average? Because it may be rigidly defined, like proper formula should be there, and based on that we will be calculating, and so that it will represent entire series of data, and it is based on all the observation of the series and capable of further algebraic treatment or calculation. For example, mean, we can use it for identifying the standard deviation or mean deviation or the t-value, all those things. It should be easy to calculate and simple to understand. It should not be affected by the fluctuation of sampling. And the item whose average is being calculated should be from the homogeneous group. And it has the stability for that particular sampling. And the commonly used average. There are mainly two types of averages for the center. One is mathematical and the other one is average of position. And there are others also is there. So first let us see the mathematical average. And they are arithmetic average, geometric average of mean, harmonic mean, weighted average. Okay, today's session we will be dealing with this mathematical averages. So first, what do you mean by arithmetic mean? That mathematic average, first one is the arithmetic mean. It is known as the average, and it can be defined as the average of total observation. It's a figure obtained by dividing the total value of the various items by their numbers. As we know, there are grouped and ungrouped data. So for ungrouped data, individual series may be calculated by adding all or summing up all the data what we get divided by the total number, and the mean is known as the symbol x bar, and it represents a summation. So let's see how to calculate it. So here a diastolic blood pressure of 10 individuals are given like 84, 76, 82, 80, 74, 96, 76, 78, 84, 90. So we know that these are the descriptive value. Okay. And there is no continuity and total number is 10. So what we need to do? Summation x, all the values, 84 plus 76 plus 82 plus. So we get total 820. That is the summation x. And the formula used for mathematical mean is summation x divided by n. Here n is 10, so 820 divided by 10 is 82. So the mean value is 82. Hope it is clear for you. But sometimes we may use this descriptive frequency distribution in case of descriptive data with more values. So here what we have to use, the same value may be there for many. So here we take the frequency of the respective value, descriptive values, and total f is the n. Summation x is the represented by summation f. That means some frequencies. So the formula is summation fx by summation f. Okay, so here we can see with one example. Okay, here again, fourth year students like marks obtained value. So here the marks obtained by the students. So 11 marks. 25 students got it. So discrete value is 11 and its corresponding frequency is 25. So summation fx means 25 into 11, 275 fx. Okay. Same way we need to find out the other one. 13 marks. How many students we got it? 20 students. So we use 20 into 13. Fx is 260. Similar way, 12 marks. 30 students got it. So 12 into 30 we got it 360. Same way 15 marks, 10 students got it. So 15 into 10 means 150. 17 marks, 15 students got it, 255. So we know that summation f is 100 students marks, that is given as like that way, and summation f into x is 1300. Okay, so apply the formula, execute the formula. So for the discrete frequency, it is this x bar or the mean is equal to summation fx divided by summation f. Here summation f is 1300 and summation f is 100. So 1300 divided by 100 and we get the mean value as 13. Similar way, in case of group data, in case of grouped or continuous frequency, the arithmetic mean is calculated by using the same formula, but instead of x, we may be having the class interval because the data may be very large. So here what we have to do, representative midpoint of the class interval will be taken. So for example, 2 to 4 means 2 plus 4 divided by 2, that means 3 is the mid value. The simple explanation. So same way, mid value of the class interval will be looking for identifying first, then same way as like in the discrete data, we multiply the corresponding frequency with the mid value and we get the summation fm instead of summation fx, and then execute the formula like summation fm in the example. Okay, so here the marks for the following data, the students, it is given almost 70 students marks are given. So those students got marks ranging from 0 to 10 is 10 students are there. So the mid value will be 5, isn't it? 0 plus 10 divided by 2, mid value 5. And so fm is equal to 10 into 5, 50. Same way, the mark range from 10 to 20 is 14 students are there. The class interval 10 to 20, 10. So its mid value of corresponding is 10 plus 20 divided by 2. So 15 is the mid value, corresponding frequency is 14. So summation fm is equal to product of fm is equal to 14 into 15 is equal to 210. Same way 20 to 30, the next class interval, 20 students got it, mid value is 25. So 25 into 20, 500. Same with 30 to 40 we got it, 16 students are there, mid value is 35, 16 into 35, 506. And next is 40 to 50, number of students are 10, mid value is 45, 45 into 10, 450. And summation F, our total frequency is 70 and FM is equal to 1770. So summation FM divided by F, 1770 divided by 70 is equal to, the mean value is 25.28. So that is about the mean value identification. Now we can see the cumulative is like in this formula we can see cumulative are upward, and so that first class is our highest cumulative frequency, it goes on declining, and less than also, so it is not commonly used. So let's see the uses of mean. Common man, why we need to use the mean? Because a common man use for his business or any day-to-day life use this mean as a calculating average and for practical sense. Which are the merits? It is defined by a rigid formula and used for the further. And based on all the observation, as like what we discussed before, it can be easily calculated and understood, and it is leastly affected by the demerits. Demerits, it's because Q distribution mean may not provide the representative value. It is influenced by extreme values. It cannot be calculated if values are not known. It cannot be determined in case of qualitative data. Perception. It gives senseless result which does not exist in the series and give wrong conclusion. So this is the common mean which we are using. Now let's see the other mathematical means like geometric mean. So when values are changing or network changing, we can use the geometrical mean as used as some measures of central tendency. So it depends on the number of observation and depends at the nth root of the product of all the nth value for variable. And the formula is n product of n square of x1, x2, x3 and is to xn, and other various values of series, and n is the number of observation and gm is the geometric mean. And geometric mean of the series of nth positive observation is defined by the nth root of their product. And for easy calculation, we use logarithm. So take log of both sides. So log of x1, x2, like that way up to xn, and it is thereafter all the log values will be added up, then divided by n. After adding up and division, take the anti-log value of the product of final result value, you will get the geometric mean. Same way in group table. So in this group 1 will be x1, x2 will be with the frequency this one, x2 to the, so like that way you can see. And for example I can give, so for this one the values are 5, 10, 15, 20, 25 and the correspondence frequencies are 30, 18, 50 and total number is 137. So what we need to do? We need to identify the log value of 5. Log value 5 is 0.69990. So it is multiplied by 30, we get 9.087. Same way, log value of 10 is 1. And when it is multiplied by 18, 18 is the value we get it. Same way, take the log value of 15, 1.1761 multiplied by 50, we get it 58. So same way, the value of 20 and 25 multiplied by corresponding frequency 40 and 10, and we get it 52.04 and 13.97 and 8.8626 for the 30. Okay, then what we have to do? Submit all the log value log x. So by adding all 9 plus 087 plus 18 plus 58.805 plus 52.04 plus 13.979 plus 8.862, we get it value 160.7736. When the total f is 137, divide this value by 137, we get it 1.1735. and take the antelope value from the table and 0.1735, we get the value as 14.91. That is the geometric value of it. I hope it is clear. Why we use geometry? Because to find the average percentage increase in price sign, because it is moving changing. It is used to measure the relative changes. It is more suitable when large weights have been given to small items. Okay, so next is the harmonic mean. What do you mean by harmonic? It's the mathematical average based on the reciprocal of the item defined as the product of the reciprocal value of a various item, and it is calculated by the reciprocal of 1 by x1 plus 1 by x2 plus like that 1 by xn divided by total number of n, or n divided by 1 by x1 plus 1 by x2 plus 1 by x3. Okay, so it is given the harmonic mean value formula is n divided by summation 1 by x. Okay, and it is the mean of the nth observation. So individual series we can calculate straight away as like s2 n divided by. And next one is weighted average. Because it is the calculation simple arithmetic, equal importance is given to all the item, we can use the mean and other one. Whereas when the values are given in different weightages and the correspondence frequency we need to use, and there we have to go for the weighted average arithmetic mean. For example, let x1, x2 and be the value of their respective value, and w1 is the weightage, and w2 and wn with the weightage given. So what we need to do, there are weighted arithmetic mean represented by the summation of the weighted is by summation w1 x1, that is multiplication of the weightage given to the correspondence data. Okay, so w1 x1 divided by total weightage, that is w1 plus weight 1, weight 2, like that way it is. And the interpretation of weightage average is when the mean is equal to the weighted average, that means equal weightage is given to all the items, whereas the mean value is more than the weighted average mean, that means small magnitude of the values are given greater weightage than the higher value. On the other hand, if the mean value is less than the weighted average value, that means higher magnitude or the large magnitudes are given higher weightage and small magnitude items are given as weightage. So far we have discussed about the different types of arithmetic mean, like symbol mean, geometric mean, reciprocal mean, weighted average. Okay, for a further reference you can go through it. And if you like this video, please don't forget to like it and subscribe to it, so that you will get the new notification. Thank you for joining with these sessions.